Okay, hello everyone, welcome back. Continuing onward, today we're going to change topics a fair amount. Let me just remind you a little bit of what we've done so far. So far I've given you a high-level bird's-eye view in the first lectures that covered the software, hardware, and human sensation and perception parts. And then I spent time going over geometric models and transformations that are applied to them, and then went through the entire chain of transformations so that you can go from defining movable objects in the world or movable bodies in the world and stationary ones, put them all together, and then determine through a chain of these transformations where your points in your original models, where you place them, are going to end up on the screen. So it'll end up with pixel coordinates at the end. There were several parts to that, and I'm not going to cover them all in detail again here, but I just wanted to remind you of that. And so we had the rigid body transformation, the eye transformation, the canonical view transformation, and the viewport transformation. And there's going to be a distortion transformation that's applied at the end to cover optical distortions, which is something we're going to talk about today. And also in these matrices, the canonical view transform broke down into a scaling and translation matrix and a perspective transformation matrix. And as one of the students pointed out at the end of class yesterday, the scale and translation matrix is a little bit too general for our purposes. So we can simplify it a bit because, by the way I set everything up in class last time, the viewing frustum is perfectly centered. And so because of that symmetry, this component goes to 0 and this component goes to 0 because r plus l is 0 and t plus b is 0. However, the near and far planes are not perfectly centered so that the origin is directly between them. So this term stays. So if you want to simplify that matrix from last time, this is how to do that.